Okay, we are starting lesson 2.2b. This is about the factor theorem. And so our very first slide is the definition of our factor theorem. It states that if a polynomial f of x has a factor, x minus k, if and only if f of k equals 0. That means you take the 0 of this factor and substitute it in place of x, and you get 0 for your answer. This also means that if you divide this x minus k into your function, you get a remainder of 0. And that's what's stated here and here. And you will see that being applied in our next set of examples. Alright, so example 1 says, find the remainder when f of x equals 2x to the third minus 3x squared plus x is divided by x minus 1. Then state whether the binomial is a factor of the polynomial. Explain why or why not. Alright, so right out of the gate, we are going to use synthetic division. I'm going to take, since this is the factor, the 0 of this would be a positive 1. I'm going to check and see if I need any placeholders. And I do not. So I'm going to say 2, negative 3, and a 1. Actually, I do need a placeholder on the end. I need to represent a 0 with my constant. And I'm going to put that right there. Okay. We're going to bring down the first term. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 1 is negative 1. 1 minus 1 is 0. 0 times 1 is 0. And 0 plus 0 is 0. Okay, so we need our answer in polynomial form with variables. So since we divided x to the third by an x, we're going to start with x squared. 2x squared minus 1x, and I'm not going to write plus 0. But that is my answer. And then the directions also stated that I needed to state whether the binomial is a factor of the polynomial. So I'm going to say x minus 1 is a factor of f of x because when dividing f of x by x minus 1, the remainder was 0. Had that remainder been any other number, then x minus 1 would not be a factor. Okay, let's also box this in. Alright, next example. Factor completely using the given factor. List all of the zeros of the function. So there are two key things here. Factor completely. And so I see here we've got x to the third, so I should get 3 zeros here and list all of the zeros. Okay, so we're going to start with synthetic division. And since they gave me the factor x minus 3, I know that the 0 will be a 3. Checking to see if I need any placeholders, and I do not. So I'm just going to fill in and start. 6 times 3 is 18. Negative 25 plus 18 is negative 7. Times 3 is negative 21. Plus 18 is negative 3. Times 3 is negative 9. And my remainder is 0. Okay, I'm not finished, but I do know that this is a factor. So check. Now I'm going to write down what we have so far. We have x minus 3, and then our answer from that was 6x squared minus 7x minus 3. And so it wants me to completely factor. So I know I have a quadratic here that I can try to factor using several different ways from previous lessons. And I have one of my zeros, which is a 3. Alright, so from here, I'm going to man factor this. So I'm going to write that here. Draw my box. 6 times negative 3 is negative 18. And my adding number is negative 7. So I need a positive and a negative, 9 and 2, so I'm going to use a negative 9 and a positive 2. Remember, when you're making the fractions, you're going to keep the coefficient, split the variable, keep the coefficient, split the variable, and we're going to drop a positive 2 and a negative 9 into the denominator. Both of these can be simplified. This one is going to simplify to 3x plus 1, and this one is going to simplify to 2x minus 3. Okay, so now we have this x minus 3 from above, then we have 3x plus 1 and 2x minus 3. This is completely factored. Now I need the zeros. List all of the zeros. So, okay, we are going to have x equals positive 3, x equals negative 1/3, and x equals positive 3/2. Okay, let's look at another example. Here it says to completely factor using the given factors, list all of the zeros. Okay, so this time they gave us 2 factors. So we're just going to start with synthetic division with the first one. So here's the factor. I need the 0. That 0 is a 2. I'm going to check and see if I need any placeholders, and I do not. And we're just going to dive right in. 2 times 2 is 4, plus 7 is 11, times 2 is 22, minus 4 is 18, times 2 is 36, minus or plus negative 27 is 9, times 2 is 18, and 0 is my remainder. Okay, that worked. Now let's do the next one straight from these coefficients here. So we're going to say a negative 3 because the factor was plus 3. We're going to say 2, 11, 18, and 9. 2 times negative 3 is negative 6, plus 11 is 5, times negative 3 is negative 15, plus 18 is 3, times negative 3 is negative 9, with a remainder of 0. Okay, so that one worked out too. Alright, so now let's write down the factored form of what we have. Both of these are factors, so I'm going to write those down. And then this is going to be my end result right here. And so we've divided by 2 x's, so we should be down to x squared. So 2x squared plus 5x plus 3. So we're still not done. We still have a quadratic that I'm going to mam factor. So I'm going to label this, and I'm going to come up here and draw my mam box and do my work here. My multiply number is positive 6 and my adding number is positive 5. That's going to result in a positive 3 and a positive 2. We have a leading coefficient other than 1, so I'm going to keep my coefficient, split my variable, keep the coefficient, split the variable, drop the 3 and the 2 into the denominator. This one simplifies. And so now I have factored this down to 2x plus 3 and an x plus 1. And now we just need all of the zeros. So our last step is to take all of this and set it equal to 0. And so my final answer for this is going to be x equals 2, x equals negative 3, x equals negative 3/2, and x equals negative 1. Alright, our next example says to factor completely using the given factor, list all of the zeros of the function. So this time they just gave us the 2x minus 1. And remember, if we're doing synthetic division, I'm going to have to rewrite that. Remember, this is a factor, and so that 0 here would be positive 1/2. So I'm going to put a positive 1/2 in the box. Check for placeholders. I don't need any, so we're going to start with 6, negative 25, negative 29, and a positive 20. Alright, 6 times 1/2 is 3, plus negative 25 gives me a negative 22, times 1/2 is negative 11, plus negative 29 is negative 40, times 1/2 is negative 20, and that gives me a remainder of 0. Okay, so keep in mind, if we're factoring completely, that 2x minus 1 is a factor, and this is going to be 6x squared minus 22x minus 40. And from here, I'm going to need to man factor that. Okay, so I'm going to come over here and take care of that. 6 times 40 is negative 240, and that gives me a negative 22. I need a positive and a negative, the larger of the two being the negative. So let's just play around. 240 divided by 20 is 12. That's not far enough apart. 240 divided by 40. 40 and 6 is too far. Let's try 30. 8 and 30. Yes, it's 22 apart. So a negative 30 and a positive 8 add to make negative 22, and it multiplies to make negative 240. I don't need these anymore. These are the ones I need. I'm going to come off to the side and make my fractions. So we have a leading coefficient of 6. So you keep your coefficient, split the variable, keep the coefficient, split the variable, and we're going to drop a positive 8 and a negative 30, both of which are going to simplify. This first one is going to simplify to be 3x over positive 4, and this one is going to simplify to be 1x over negative 5. So I'm going to come back over here, bring down my 2x minus 1, and then we're going to have 3x plus 4 and x minus 5 in parentheses. That's factored form. Then my zeros are all going to be positive 1/2, negative 4/3, and a positive 5. Alright. Our next example says factor completely using the given factor, list the zeros of the function. This time we have a nonlinear term that we are dividing with, and so because of this squared, I'm going to need to use long division. So out to the side, I'm going to have 2x squared plus 1, and we are dividing that into 6x to the 4th minus 20x to the 3rd minus 19x squared plus 10x plus 8. And we are focusing on 6x to the 4th. So what can I multiply to 2x squared to get 6x to the 4th? 3x squared. Distribute that back. 3x squared times 2x squared is 6x to the 4th. 3x squared times 1 is 3x squared. And I'm going to write it under its like term. I'm going to leave this part blank. Subtract, subtract, cancel. I'm going to bring this down. This is going to give me lost my train of thought. Negative 22x squared and then we are going to say, what do I multiply to 2x squared to get negative 20x to the third? Sorry, I was looking for my highlighter. There it is. 2x squared times what gives me negative 20x to the third? And that we're going to multiply that by negative 10x, distribute it back. That's going to give me negative 20x to the third minus 10x. So I'm going to write that over here. And then there's not going to be anything there at all, so we'll end up bringing that down. Let me bring this down too. Alright, so we're going to subtract, and that's going to cancel, bring this down. Going to give me 20x plus 8. And now we're focusing on what I can multiply to negative 22x squared to get 2x, what can I multiply to 2x squared to get negative 22x squared? And that's going to be negative 11. Distribute that back. Negative 22x squared minus 11 minus cancel, and I'm left with a remainder here, 20x plus 19. So my direction said factor completely using the given factor, list zeros of the function, and so here I'm going to say 2x squared plus 1 is not a factor of g of x. And when I'm looking over here at my notes that we worked out during the school year last year, it looks like we edited that one to be a minus. So what I'll do is I'll go back and make a separate video for that and make this 2x squared minus 1. I'm not sure why it printed as plus 1, but we can fix that. That way it'll give you a good example of what happens when you have zeros that aren't rational. Alright, so next example. Factor completely using the given solution. List all solutions to the equation. Okay, so they've given me an equation, and they gave me a 0. So this means that whenever I divide using synthetic division with this one, that I should get 0 for my remainder. So let's go ahead and set that up. Checking for placeholders as I go. I don't see the need for one. And let's start. Bring down the 48. We are multiplying 48 times 2/3, and I get 32 plus a negative 80 gives me a negative 48. So when I multiply that to 2/3, I'm going to get a negative 32 plus 41 is positive 9 times 2/3 is a 6. And when I add those together, my remainder is 0. Okay, so from here, that means that my answer is 48x squared minus 48x plus 9. And then since this gave me a remainder of 0, that means that 3x minus 2 is that factor from this 0. Now I see that I need to try to factor this. So I'm going to use MAM to factor that. I'm going to come over here to the side and multiply 48 times 9 for my multiply number. And that is 432. And my adding number is negative 48. So my multiply number is positive and my adding number is negative, so both of those are going to be negative. If I play around with this, I know it's not going to be a 10, so I'm just going to start with a 12. 36 and 12, yes, that adds to make 48, so I guess lucky that time. Negative 36 and negative 12 do add to make negative 48. Okay, so now remember you need to start with your leading coefficient, keep the number, split the variable, keep the number, split the variable, and we're dropping these into the denominator, and we're simplifying. 48 over negative 36 will simplify to 4x over negative 3, and 48x over negative 12 will simplify to 4x minus 1. Alright, so if we're factoring completely, I need to write these down. That's completely factored, and then the zeros are going to be if I set these equal to 0 and solved. So positive 3/4, positive 1/4, and positive 2/3. Alright, a couple more slides. When factoring a higher order polynomial, there are different types of factors. You can have a linear factor, degree of 1, in the form of ax plus b, where a and b are any type of number, or irreducible quadratic factors. Degree of 2 cannot be factored using rational numbers. And so here we're going to show you what that would look like when asking for each of those specific types. So if I'm given this function and it has a factor of 2x minus 1, and it says to write g of x as a product of linear and irreducible quadratic factors, that would mean since this is a factor, and then it's like this is what I got from doing synthetic division, but I can't factor that anymore, not evenly. And so I could check. I'm going to draw a line out here and check ma'am. A positive 7 and a negative 6. So that would mean both of these need to be negative, but the only way to make 7 by multiplying is 7 and 1, and negative 7 plus positive 1 does not equal negative 6, so this can't work. I'm going to write doesn't work. So when you can't factor it anymore and it's quadratic, then if you were to write the product of linear factors, this is what it would look like. X minus 3 minus the square root of 2, because you would have to do the quadratic formula for this one. So let me highlight that. Irreducible quadratic factors. So x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 7 all over 2, 1. 6 squared is 36, and 36 minus 28 is 8 all over 2. 6 plus or minus 2 square roots of 2 over 2, and that will simplify to be 3 plus the square root of 2. And so that is why they wrote it like this. If I'm writing it as a product of linear factors, then I would move these to the other side. X minus 3 minus the square root of 2, and x minus 3 plus the square root of 2. And so if I'm listing all of the zeros now at this point, that would be x equals 1/2 from the original, and x equals 3 plus or minus the square root of 2, based on this work right here. Last one. Same type setup. They've given us a factor, they've given us a function to consider. They've factored everything out, so everything was factorable. They wrote the product of linear factors, which will be the same if your quadratic factors can factor. And then if I'm listing the zeros, it's going to be negative 3, negative 1/3, and a positive 1/3. All right, that's it for lesson 2.2b.